Well, hello there. My name is Dr. Wisby, and I'm going to be your instructor this summer for College Physics 1. This is the algebra-based physics course, and we are going to cover materials from Physics 1, which include Newtonian mechanics, so um, heat, the transfer of heat, rotational motion, and conservation of energy, amongst other things. We're going to be using the book Pearson, and everything can be found by going into the Canvas page. So I have structured it in a way so that everything is right there for you, and so you can go through it as fast as you want to. There will be deadlines, um, and those will be outlined on the software. But let me tell you a little bit about myself. I do research here at St. Louis University. My research is in quantum information. I've taught college physics for a number of years, and I'm a big believer in doing practice problems. So I'm going to be doing a lot of problems, and I'm also going to have you do problems as well too, because I think the best way to really learn physics is by doing it. So um, there's of course going to be the textbook, which I highly recommend reading as much as you can. I understand that time is a little short this summer, and so um, our time is limited, and it is going to move through things a little bit quickly. And so my intention is to do lots of examples, which include homework problems, um, and also demonstrations. So I'll try and make a lot of videos to help you understand the concepts of the material, and then we'll work on problems together. And so I highly recommend using paper and pen to solve your problems. The beauty of having a background distraction. So one advantage of having paper is that it never blinks at you. You can put everything here on your pad and you can see it. You never have to open anything up, and it doesn't blink at you because anytime you have a tablet or a phone, there's always going to be a million notifications. And so some problems do take a little bit of thought. And I feel like personally not having electronics constantly beeping at you is advantageous, but of course it's up to you, whatever the medium is that you work the best on. So I will leave that up to you. Um, for all of the math in the class, because physics really is problem based. The thing that you, I think, should learn from this is how to solve problems. Now, I understand that many of you may be afraid of physics, but let me assure you that it is my job uh, to make physics not suck. And I'm going to do everything I can to do that. I'll be available. So if you would like to email me to get help with the problem, I'll be available. I will try to be available during the day most of the time because I know that you'll be working on the homework during the daytime, presumably. We only have 6 weeks, and so I would expect that you'll be working on this every day. Um, because there is quite a bit of material to get through. So I will be available by email. Or we can also use Zoom to video chat. I have a 4K webcam, and so if you have any issues, um, problems that you'd like to work through, I would be happy to take a Zoom call and we can talk about it. I understand some of you might be in different parts of the world, and so I will do my best to accommodate whatever schedule you have. I will have to sleep sometimes, but we could either meet in the morning or we could either meet at late at night if that's what you need. So just let me know. I'm happy to meet with you. I know that many of you are not in St. Louis, and so but I'll be available by email and by Zoom, and I will have my email on. And so I will try to respond to you as quickly as I can. Because I know that we're going to move through this quickly, and so I will endeavor to be very responsive. So let's take a look at the syllabus because it has a lot of important information. Um, Primarily, how to contact me. So you can, as I mentioned, you can, of course, email me and let me share all my contact info. All right. So here's our course. I'm Dr. David Wisby. I'm in Shannon Hall, room 113. I don't think many of you are here, so that's not really important. But the best way to get a hold of me is davidwisby@slu.edu. I will have my email on and I will be responsive. Um, these office hours are a suggestion. Um, um, so but you can, Okay, so my office hours are basically every day from 10 a.m. to 4 p.m. I could be working in my lab or preparing lectures, but if you would like to make an appointment, I can set up a Zoom call or I can just respond to you in an email. You can take a picture of your screen, take a screenshot, email it to me, and I can try and answer you that way as well. So. I know that some of you maybe not video chatting won't work, so we can definitely correspond by email, and I should be very responsive. The course should be available through Canvas, and so if you go to the Canvas webpage, then you should be able to get to Pearson. But that's the most important thing. The book and all the homework will be through the website, and you can access it through Canvas. It's going to ask you to possibly pay for online access, and so you'll need to use a credit card in order to do that. And I will have more information about payment methods for that as the time approaches. But you will access everything through Canvas. So if you want to know what to do, go to Canvas and all the information is going to be there. This class does meet the core requirements for ways of thinking, natural and applied sciences. And so this College Physics 1 will meet that core requirement. We're not doing the lab at this time, and so you may need to take the lab section for the course later in order to fulfill the requirement. That should not be an issue. You should contact Kyle Mitchell later or and he can get you into a lab section during the regular semester. So, um, but we're not going to worry about that right now. This is only the lecture component of the course, and everything's going to be online. The tests, the homework, everything will be online. For the tests, they will be proctored, and so ideally you will have a web camera, and we will do everything using a lockdown browser. So there will be some software that you need to install, and so I will create some tests, and so that you can make sure that you have all of the software installed on your computer before we actually do a test. Okay, the test will be online. There will be a video of you, which will be destroyed after the course. But mostly I want to see your desk, your computer, and then any paper or scratch work that you're working on. Okay. And just to be upfront about the test will basically be very similar homework problems that you worked on. Okay. And so my policy is that if you haven't seen it in the lecture or I didn't talk about it, and you didn't do it on the homework, it's not going to be on the test. So the test will only be what we covered in class. There won't be something that just is completely covered or completely out of nowhere. Um, now, um, we're not going to cover every single section in the book. The ones that are covered will be on the Canvas page and under modules. And so you can go to the module for each chapter and we'll have the different sections. And then there will be a video, a short video for each section. And then there will also be example problems. So you can watch the videos. I hope that they're helpful. I'll do a lot of example problems, and you'll be going to my YouTube channel. They should all be organized, and you can access them all that way. Okay. Um, so, and I'll put links to those videos in Canvas. So if you ever don't know what to do, go to Canvas. Everything can be found on the Canvas page for this class, including videos from me doing problems, the lecture slides that those are those are pretty helpful. They are a summary of the chapter. So if you want to quickly go through the material, you could look at those lecture slides. They have problems with worked out solutions on those. Those are very useful. The book is always good too. I always recommend reading the book if you can. Um, but all of it's going to be online through the Canvas webpage. So when you're ready every day, when you wake up, you're going to do physics, log into Canvas, and it will all be right there. And you can, if you want to, you can move through it as quickly as you want. But I will have deadlines to keep you on track with the semester or with this course over the summer. And the course will require you to move at a moderate speed, which means that you should, of course, start on it right away and don't wait until the end to do all of the assignments. Um, and there's going to be, we're going to cover about uh, 13 to 14 chapters. And let's take a look at the breakdown of the grading scale. So, of course, always be kind and respectful to other people and any kind of interactions that we have online. And in a way, this is, um, training for your job. So someday you'll have a job where you work at a company, and so it's important um, to be professional and nice to other people. Okay, so I reserve the right to lower the cutoff, meaning that I could lower the passing grade for an exam. I won't raise it though, so I won't ever do that. I could make it lower depending on how everyone is doing. Um, another important point is that all of your work should be your own, and you should not use AI to solve the problems. It is okay to get help. So, uh, you know, we're on a tight schedule, and so it's okay to look online for help. However, it's really, really important that you don't use some kind of software to do the work for you because that is not going to be available in the exams, and it's important that you do the work yourself. Now, whatever your program is, okay, it's important to remember that physics can help you. And I know that maybe some of you are thinking, oh, why do I have to take physics? Well, tell you why. The elders in your program many years ago decided that it is important. And here's the reason why. Because Physics really is the basis for all of science that we know it. It really sort of defines the scientific method because, what you should take away from this class is you may not remember all of the equations. Hopefully you remember some of the equations, but it's the way that you go about investigating something or doing research. Each of you that are in this class are in the some type of scientific field, in health, in medicine, but you're taking this class for a reason. And so, whatever your field is, it's important to realize that uh, the scientific method is important for finding truth. In our society today, there are many questions, right, about what is true and what's real, right? Especially in medicine, there's a lot of misinformation out there. And so it's important for you to understand how do we, as medical professionals or scientists, um, how do we know what is true? And this is really important for people's health because, for example, medications. When a medication is tested, right, they do it using the scientific method. This is how we know that drugs are safe. By the time a drug reaches market, it has been through rigorous scientific review, including testing on human beings. Um, and scientists have studied it extensively and determined that it is safe. And they've made that determination using the scientific method. Without the scientific method, we have no way to know if something is safe or not. For example, sometimes they have health magnets at the store, and these are supposed to be medicinal in some way, right? And so if you wear magnets, it's supposed to, cure arthritis in your joints, or help you with migraines, or who knows, or crystals, right? If you get a nice crystal, it's supposed to increase your health. Okay, well, without the scientific method, there's no way to determine if this is real or it's nonsense, right? And so it's important for you to understand the scientific method and to believe in it so that you can help your patients, right? Because when they're going to come to you as a trusted medical provider, and so you need to be able to know where information comes from and if that information is reliable. Because without science, you could be getting health advice from your aunt's brother's friend off the internet, and that usually doesn't work out well. Um, we've all lived through COVID, and there was a huge backlash to just science in a way, the medical industry also. And so, we need to deal with this fact that there's a lot of misinformation out there. Um, and, you know, this is a very real issue. And so, physics, the scientific method that we have used and developed in physics over the years, is also the basis for medicine, right? Repeatable, testable hypothesis that we use experiments to test to find out if something is real or not. Now, in physics, we don't usually use human subjects or animal subjects, but in medicine, you do. And those same principles apply in medicine that apply in physics. You test your hypothesis to see if it's real. If your hypothesis agrees with the experimental data that you collect, then it becomes a theory. And once it becomes a theory, then we would say that it's true, right? Because in science, the word, if something is theoretical, that means that it's been proven, right? Now, in normal colloquial English, we say something says, oh, it's theoretically true. Well, to a normal layperson, non-scientific person, that means it might be true. What they're really saying is that's a hypothesis, okay? But in science, a hypothesis and a theory are very distinct and separate things. A hypothesis is something that it's your idea of how you think something is before you've had time to test it with an experiment or collect data, right? Once something is theoretically proven, that means that you have tested it. It agrees with your data, and it's been reviewed by you and other scientists to make sure that it makes sense. Right? You've analyzed the data, you spent time understanding it, and for all that we can tell, it's real. If there is such a thing as real, but it's proven, right? Um, and so if you don't take away anything from this class, that's the important thing. Because if you're in the healthcare industry, people will come to you and ask you all kinds of crazy questions. Like, if I drink Drano, is that going to cure COVID? If I put magnets on my head, will it make my migraine go away? You need to look at it and say, I don't know, is there any evidence from this? Where can we get evidence from? Uh, what about CNN and Fox News? Are those good sources of scientific information, or do you need to read a journal that was reviewed by scientists? Right? So that's the big takeaway from this class is understanding the scientific method, using the scientific method to solve problems based off of data. Because at the end of the day, it doesn't matter what you think or what you feel, right? It matters what the evidence says. In my own experiments, I recently had a paper and I had a hypothesis. I thought, there's a relationship here that I have observed, and I really believed that. But as I collected more and more data, it turned out that my hypothesis was not true. There was just no evidence for it. And so I had to publish a paper, and explain that, this is how I thought it was. And, uh, that paper reflected the fact that my hypothesis was wrong. It just didn't work out. And that really hurt, because I thought it was a certain way. And I remember I asked ChatGPT, it's okay to ask it to kind of get an idea and maybe suggest references. And so I said, ChatGPT, is this true? Uh, is there really some effect there? And I was looking at, do gamma rays affect microwave circuits, right? Do they shift the performance of it? And I was like, it must be true. I definitely believe this. And so, and I asked ChatGPT, I was like, is this true? And ChatGPT was like, yes, of course it's true. If you know, if you expose a microwave circuit to radiation, it's going to behave in this way. And I was like, oh, I knew it. I knew it. I was right all along. And I was like, okay, give me a reference for that, chat. Chat, show me where you found this information. And it did, and it was actually from my own presentation that I gave at a conference based off of preliminary data, which turned out later to be wrong. So ChatGPT had found an abstract from me on the internet, and it was repeating it back to me, even though it hadn't been proven. And so that just shows you that uh, it's okay to use AI, but you need to have evidence, okay? Because you have to check it. It'll just find something on the internet and it will repeat it to you. That's really what it's doing. And I don't know about you, but there are some things on the internet that might not be completely true. But AI doesn't know how to differentiate that unless you tell it. And so that's why humans need to know what's true or not. So, uh, so my policy is it's okay to use AI initially to get some idea, but you have to be able to solve the problems, okay? I would recommend trying to solve the problem you're first. Don't look up the answer first, okay? Spend some time on the problem. Now, there's going to be a homework due every few days, and so time is limited. You won't have uh, infinite amount of time, and so you need to set limits for yourself and say, okay, I have, maybe 10 or 15 minutes for this problem, If there are 20 problems, hey, um, if I spend 10 minutes on each problem, that's 200 minutes. Um, so you need to decide, what do I have time for here? But try to solve it first. And if you can't, I understand you're going to need to get help. There's a lot of resources on the internet. Um, AI can give you clues about how to do it, but it's important that you solve the problems yourself. Okay? That's the big takeaway. I know that AI is here to stay, but it's also important that human beings still know how to tell if something is true or not.